Have you ever wondered what holds the universe together? I mean, really together? From the water you drink to the screen you're watching this on, everything is made of atoms, and these atoms are constantly linking up in a cosmic dance. But how do they do it? What's the secret handshake that lets them form everything we see and touch? Well, get ready, because today we are diving deep into the world of atoms to uncover the two main ways they bond, ionic and covalent bonding. It sounds complicated, but I promise by the end of this, you'll see it's all about sharing and stealing electrons, that is. So let's start with the big picture. Atoms are like tiny, tiny solar systems. In the center you have the nucleus, which is positively charged, and zipping around it are negatively charged electrons. Now atoms are happiest, or what chemists call stable, when their outermost shell of electrons is completely full. Think of it like collecting a full set of trading cards. It's just so satisfying. But most atoms don't start out with a full set. They're missing one or two, or maybe they have a couple of extras they'd love to get rid of. This is where the magic of bonding comes in. To achieve that happy, stable state, atoms will interact with each other, either by giving away, taking, or sharing electrons, and that interaction is what we call a chemical bond. First up, let's talk about ionic bonding. This is the drama-filled, high-stakes romance of the atomic world. It's all about one atom giving an electron and another one taking it. Think of it as a transfer, not a share. This typically happens between a metal atom and a non-metal atom. Metal atoms, like sodium, are the generous givers. They usually have just one or two electrons in their outer shell, and they're thinking, man, my life would be so much simpler if I could just get rid of this extra baggage. By losing that electron, the shell underneath becomes the new outer shell, and surprise, it's already full. On the other side, you have the non-metal atoms, like chlorine. They're the eager takers. They're super close to having a full outer shell. Maybe they just need one more electron. Chlorine is thinking, I'm so close. If only I could find one more electron to complete my set. So what happens when a giver like sodium meets a taker like chlorine? A deal is made. Sodium gladly hands over its extra electron to chlorine. Now here's the crucial part. Remember that electrons are negative? When the neutral sodium atom loses a negative electron, it becomes a positively charged ion. And when the neutral chlorine atom gains that negative electron, it becomes a negatively charged ion. And what do opposites do? They attract. This powerful electrostatic attraction between the newly formed positive sodium ion and the negative chloride ion is the ionic bond. It's a super strong connection that holds them together, forming a new compound, in this case, sodium chloride, which you probably know as table salt. So every time you sprinkle salt on your fries, you're looking at millions and millions of tiny ionic bonds in action. It's not a partnership. It's a transaction that leads to a powerful attraction. Now let's switch gears and talk about the other major type of bond, covalent bonding. If ionic bonding is a dramatic transfer, covalent bonding is more like a friendly, cooperative partnership. The word covalent even has co in it, like coworker or cooperate. This type of bond usually happens between two non-metal atoms. These atoms are in a similar situation. They both need electrons to fill their outer shells. But neither one is strong enough or willing to just snatch electrons from the other. Instead of giving and taking, they decide to share. It's the ultimate teamwork makes the dream work scenario. They come together and pool their electrons, creating a shared pair that orbits both of their nuclei. Let's take the simplest example, hydrogen gas, or H2. A hydrogen atom has just one electron, but its first shell needs two to be full. So when two hydrogen atoms meet, they can't just take an electron from each other. Instead, they each put their one electron into a shared space between them. Now each hydrogen atom gets to count both of those electrons as part of its shell. It's like two friends who can't afford to buy a video game on their own, so they chip in together and share it. By sharing that pair of electrons, they've formed a single covalent bond, and both atoms become stable and happy. This sharing creates a very strong, direct link holding the two atoms together, forming a molecule, and this sharing can get even more complex. Take oxygen, the stuff we breathe, or O2. An oxygen atom needs two more electrons to fill its outer shell. So when two oxygen atoms meet, they can't just share one pair. That's not enough. They end up sharing two pairs of electrons. This is called a double covalent bond. It's like that video game example, but now they're chipping in for a game and a pizza. The more electrons they share, the stronger the bond between them. Water, or H2O, is another fantastic example. Oxygen needs two electrons, and each hydrogen atom has one to share. So, the oxygen atom forms a single covalent bond with one hydrogen atom, and another single covalent bond with a second hydrogen atom. Everyone gets what they need. The oxygen shares with two hydrogens, and each hydrogen shares with the oxygen. It's a beautiful, stable arrangement that gives us the substance essential for all life. So let's do a quick recap to make sure it all sticks. In the atomic world, it's all about getting a full outer shell of electrons. Ionic bonding is the give and take method. A metal atom gives away an electron, becoming a positive ion, and a non-metal atom takes it, becoming a negative ion. The opposite charges then attract each other, sticking together like tiny magnets. Think salt. Covalent bonding, on the other hand, is the sharing is caring method. Two non-metal atoms share pairs of electrons to make sure everyone has a full outer shell. This creates a strong link holding them together in a molecule. Think water or the oxygen you're breathing right now. One key difference to remember is what they form. Ionic bonds create a crystal lattice structure, a vast, repeating grid of positive and negative ions. Covalent bonds create distinct, separate units called molecules. These fundamental differences in bonding are why salt is a hard, brittle crystal and water is a liquid at room temperature. The very properties of everything around us are dictated by whether their atoms are stealing or sharing electrons. It's a simple concept, but it governs the entire structure of matter. From the DNA in your cells to the rocks under your feet, it's all held together by this constant, invisible dance of electrons. It's the fundamental force of chemistry, happening all around you, all the time. So the next time you look at the world, remember that you're not just seeing objects, you're seeing a grand collection of atoms, all connected in fascinating ways. Whether they're forming ionic attractions or covalent partnerships, they're constantly working to find stability, and in doing so, they build the entire universe. It's pretty mind-blowing, isn't it? I hope this helped you understand the basics of how atoms stick together. If you enjoyed this journey into the tiny world of chemistry, please hit that like button and subscribe for more deep dives into how our world works. If you have any questions or ideas for future topics, drop them in the comments below. I love reading them. Thanks so much for watching, and I'll see you in the next video.